everyone, welcome back to my channel. Today we are going to learn more in organic chemistry, and today we are going to learn about the different formula that are used in organic chemistry. Those different formula are structure one, the molecular one, and empirical one. Let's go into the detail of each of them. So why it's important to predict the properties of a compound, we need to know the structural formula. Without the structure, without the functional group, you cannot tell what type of properties are going to be there, or with which reagent or with which compound or molecule it can react. So the structure formula shows the position and nature of functional groups. So for organic compounds, we have three type of formula. One is the structural formula, second is the empirical formula, and third one is the molecular formula. Let's go into the detail of each one of this. First of all, we are going to learn about the structural formula, because it would be more fun, as you have to make more molecules you can draw, or you have to use your mind and it will capture you. The other two are important with reference to the calculation one, so you should have the calculators for those one. Let's go to the definition of each one of the following. The empirical formula shows the simplest whole number ratio. Now, how could you say what is the simplest whole number ratio? The simplest whole number ratio means if you have a molecule like C6H6, so what would be the structure? What would be the simplest whole number ratio? That would be 1 and 1. It would be CH. If I talk about glucose, that is C6H12O6. So if we make a simplest form of this one, it's 1, 2, and 1 with reference to the 6. So it would be CH2. Now, many molecules have the same empirical formula. Many molecules can have the same molecular formula. Now, the only thing that is going to differentiate these is your structural formula, which tells you what type of functional group is present. That's why it is important to learn the structural formula. Now the molecular formula or molecular formula tells you about the actual number of atoms. For example, in glucose, the actual number of atoms are 6 carbon, 12 hydrogen, and 6 oxygen. The last one is the structural formula, which shows you the position of functional group or what type of functional group is present. So let's go into the structure details of structural formula. So structural formula identifies the location of chemical bond, like where is the double bond present? Is it present on position number 1, position number 2, position number 3? Where is it present? So what is structural formula? Structural formula basically tells you how many bonds are there, what type of bonds are there, whether there would be a double bond between carbon and carbon, whether there would be a carbonyl group present, an alcoholic group present, or what is present actually. So structural formula gives you the detail of everything. So structural formula consists of basically the symbol of atoms. For carbon we use C, hydrogen, this was very basic thing, and we are going to connect them with very short lines of like CH, how we are making CH, and then we have to represent how many bonds are there, whether single, double, or triple. So here is a formula of ethane. Now the general formula of ethane, you might have learned this in the previous video. It's CnH2n plus 2. So if n is 2, it would become C2H6. So how to represent it now? Just have an idea that each carbon has 3 bonds with hydrogen and 1 with carbon. So the simple structural formula would be like this. Let's learn the more structures. The molecular formula actually gives you number of atoms of different elements in one molecule or other. However, it won't give you any information about the way the atoms are arranged. So the arrangement is only explained by the structural formula. For example, if we learn about C3, H, 6 and O. Now there can be two possibilities of making this formula. Just some, it can be OH if O is present, or it can be a carbonyl group. So you have to think very carefully whether it's a carbonyl group, it's an ester group, ether group, or what type, whenever oxygen is present, or aldehyde or ketone. So you need to look into the details of how many carbon number or the general formula. All the general formulas are discussed in the in some other video. You need to watch that video to learn the general formula. So whatever general formula fits on this molecule one, so we are going to give this compound the same general formula. To find the exact structure formula, we need to know more about the functional group. Now there are two. One is the aldehydic group, this one, and the other one is ketonic group, in which the carbonyl group is accompanied by R group on both sides. Okay, while in aldehyde group, one side has hydrogen while the other side has the R group. So this one is R group. So let's gather the information. So how do we gather information? There are several methods. Number one is the instrumental method. For example, if we talk about the spectrometry, there are the spectrometric methods which give you the peaks, and these peaks tells you what type of group can be there. For example, if there is a certain value, you need to match that value with your database and you'll get the type of functional group that is present. The second one is the physical properties, how they look like, what is their melting point, boiling point. You know that every compound has a very specific boiling point or very specific melting point. So the two compounds cannot have the same one. So you can easily check it from the database. Or the chemical properties, like the chemical properties of ketones and aldehydes are quite similar, but they also differ. They give different type of compounds, so we can check the chemical properties as well. Now how we are going to represent is there are different ways to represent this. Let's make a molecule and we are going to see how they are represented. For example, we have butane. Now butane can be written in an expanded form where we have to mention each one of the atom. We have 4 carbon and we have 10 hydrogen. Now we have make this formula in expansion form. We can also write it in the condensed form without mentioning these lines. This is the condensed form in which it's the bonds are not shown, whether they are double or triple, whatever it's not shown over here. Now what is the skeletal one? Skeletal one is that gives you a basic skeleton. There's no need to mention what type of atoms are present. So but keep in mind that this skeletal formula, the each point, the each, you can say the corner, or this one represents the carbon. Okay, and these one lines that are in between these bendings, these represent the single bond. If a double bond is present, then it would be written like this. Sorry, it would be written like this, that this double bond is present. Then you can adjust the hydrogen number accordingly. So what is the condensed structure? In a condensed formula, what is going to happen, you just have to write the carbon number and the hydrogen number and nothing else. There won't be any lines, there won't be anything. This is the simple condensed formula. While the this one, if you look at this one, you can change it, like whether it's present between carbon carbon here, carbon hydrogen, if some X is present, if some O is present, let's see, or if some nitrogen is present. So we can just change our type of bonding, like whether it is double, single or triple. So you can easily make it. Now the skeletal formula shows wherever there are the bendings, those are the carbon ones. Like here we have carbon, here we have carbon, here we have carbon, here we have carbon, and on the corners we have carbon. Now look over here, how many carbons are there? 1, 2, 3, 4, 5 in a single chain, or in a longer chain we have 5 carbons. Let's make a longer chain. 4 and 5, and 1 is present as a substitute on carbon number 3. 1, 2 and 3, let's say it's a carbon. Okay, so there are 6 carbon basically. Now a double bond is present at carbon number 2. You know very well that we name or we mention the the double bond from the nearest position. So here we have double bond, we'll make a double bond here in your expanded form, and then we'll just adjust the hydrogen number wherever the hydrogen is present. Here we have CH3, here we have CH3, here we have CH2. No hydrogen with this one, as already 4 bonds are justified. Here we have 1 hydrogen, and here we have 3 hydrogen. So this is how you make the molecule. Now the another example is this one, where we have amine group as well, NH2 group as well, and the carbonyl group as well. So when we make the structure, we have C, then we have again C, with which we have amine group, then we have carbonyl group, and then we have carbon with R, with OH group. So this is how you make it. Now here we don't have any carbon because they have mentioned here that we have hydroxyl group at this end. So at the end we have hydroxide group, not the carbon one. Now you can just make the hydrogen numbers, how many hydrogens can be there. Here it can have 3 hydrogen, here it can have 1 hydrogen, and the other are already justified. So this is how you make the structural formulas. Let's go to the more examples. Like if this is the expanded form, how to make it or how to convert it into a structural form. Let's look at it. So we have 1, 2, 3, 4 carbons. Let's make. We have a straight chain, or you can also make 1, 2, 3. So this is carbon number 1, this is carbon number 2, and this is carbon number 3. So we just remake it. It's like this. Then we have one substitute one on position number 2. Let's 1, 2 and 3. Even if we start from the other side, it's still number 2. We have CH3 over here. Let's say we have 1 over here, CH3, and we have hydroxide over here. So how to make this formula? Let's learn the geometry. Then it won't be bent, it would be straight, because there are 4 different functional groups present and each angle would be 90 degree. So it would be like this: carbon, 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 and then the hydroxide group. Now the next one is the ester. Now look over here, we have 2 ethyl group on both sides. Now this is 1 carbon, this is 2nd carbon, this is 3rd carbon, this is 4 carbon on the other side. Let's C prime or C prime. Okay, now here we have in center in oxygen, and on the sides we have our methyl group with 2 carbons, so we have a bending over here. Now the third one is the ketonic, is the same ester, but with the different number of carbons on both sides. Here we have 2 carbon on each side, here we have 4 carbons, but on one side we have 1 carbon, and on the other side we have 3 carbons. So here is carbon number 1, this is carbon number 2, this is carbon number 3, and this is carbon number 4, as this one is present as a substitute on carbon number 3. There was 2. This is carbon number 1 and this is carbon number 2. This is how you make the chemical formula. These are the general formulas you can find in the other video as well. So see you in the next video. If you have any question, you can ask in the comments. If you have any confusion, you can also ask, and do practice these structures, as practice makes a man perfect. So see you in the next video with the other topic.